Hi, this instructional video is about exponents, the rules of exponents that is, and this particular one is about multiplication properties. Now there's three types of multiplication properties. First we have product of powers, power of a power, and power of a product. Sound like a tongue twister, don't they? But let me give you a quick example for each one of them. The first one, it says product of powers. So here's a number with the power. And here's another number with the power. So here's a number with the power, here's a number with the power, and we're going to take the product of that. And that's why it's called product of two powers. So in this case, the rule is if the base of the two products are the same, then you're supposed to add the exponents. So in this case, you get s to the 2 plus the 3. So which in this case, it becomes s to the 5th power. That's it. Let's try number 1, 2, and 3. All right, so you said, since the bases are the same, 7 and 7, when we're taking the product of the two bases that are the same, you're supposed to add the exponent. So this just simply becomes 7 to the 5 plus 7, which equals 5 to the 12th power. Should you evaluate this? Unless you have a calculator, but that should be a good answer for your teacher. And how about this one? If you said, well, it's a negative integer, negative base, but as long as they're the same, the rule is you're supposed to add the exponents. So let's go a little faster. 3 plus 8 is 11. And that's a good answer right there too. Now in this case, we have 3 bases that are the same. The rule is still the same. You take each of their exponents. That's a 1. You knew that. So it becomes x to the 2 plus 6 plus the invisible factor 1. So the answer becomes x to the 2 plus 6 is 8 plus 1 is 9. And that's the answer for number 3. Power of a power. If you have, for example, y to the 2nd power raised to another power, let's say 8. Well, that's kind of like saying y to the 2nd times y to the 2nd of the y to the 2nds. And coming back to the rules of product of powers, you're supposed to add the exponents. So you could tell right away if you add all the exponents, 2, 4, 6, 8, 10, 12, 14, 16, y to the 16. Or you could have just simply said 2 times 8 is y to the 16. Either way, I think you'd rather do it this way better, huh? Oops. So now you try that, and that one. Okay. Now, unless you really wanted to go like this, 3 to the 5th times 3 to the 5th times 3 to the 5th, you add the exponents to become 3 to the 15. That's a good answer. Or if you just simply said 5 times 3 is 15, that's even a smarter answer than that. Okay? Now this one, 2 to the 6th is x to the 12. That's all there is. In this case, r to the 14. There you go. And now this one, power of a product. Now, power of a product. Here's a product of two numbers, let's say. And here's a power. Now, you could just simply say 7 times 4 is 28 to the 2nd power. But the rule is, in case sometimes it's not an integer, the rule is that you're going to take that exponent and then multiply to each of the exponent inside. So in this case, it becomes 7 to the 2nd power times 4 to the 2nd power. Okay? And in this case, of course, it becomes 49 times 16, which becomes some huge number. And I just checked with the computer and it says 784. And of course, 28 times 28 is also 784. But in this case, it becomes 2 to the third and 5 to the third. And that's a good answer. Let somebody with a calculator evaluate that one. Then what about this guy? So if you said negative 3 squared times 5 squared, that's a good answer. Or you could have said 9 times 25. That's a good answer too. And this one? If you said negative 2 cubed, x cubed, y cubed, that's good. But if you went ahead and evaluated this exponent, which becomes negative 8, x cubed, y cubed, it's even a better answer. Okay, there you have it.